Alright, so as of now we've written a little program that did payroll. It asked for the user's salary and weekly whatever, and it multiplied those two together and it gave us some output. So operators. Operators perform operations on data. There's the standard calculators one, addition, subtraction, multiply, and divide. There's the equal sign, which is known as the assignment operator because we're assigning things. How do you compare two things? How do you see if A is equal to B? If what the equal sign means is assign a value. Well, you use two equal signs to do a comparison rather than just one. Then there's the arrow, arrow going one way and the arrow, arrow going the other way. If you're displaying messages, you have to use arrow, arrow going off to the left, and you're sending them to C out. That stands for output. If you're letting the user type something in, you use CIN. That stands for input, arrow, arrow, hours. And as Olivia noticed, if you use C out, arrow, arrow, hours, or whatever, it won't work because C out can only accept a stream of characters, a stream of data with the less than, less than. If you want input, you use the input stream. These are known as streams, the stream insertion operators. That's why it says IO stream up there. If we didn't do # include IO stream, then we wouldn't have C out and C in to play with. Cool. Then there's punctuation. Parentheses, braces, commas, and semicolons. Semicolons are used to terminate a statement. Parentheses group together things, like if you're going to do 2 times 3, but you could put those inside parentheses. You also put things inside parentheses that are inside function calls. If you're going to call a function, you would put the values you're passing to that function inside parentheses. Have we talked about functions yet? Not really. Then you have the curly braces. The curly braces denote blocks of code. When you're writing your program, all of your code has to be between braces. So if you do int main, open brace, close brace, and then you have your code, it's not going to work. The code all needs to be between these two braces. Now when you start writing more complex statements, they may not all be in main. You may go and write code inside of another function, but that code is still going to be within its own pair of braces. If you even open up another file, because you're writing a really complex program and it needs multiple files in order to conceptually be comprehensible, code's still going to be between braces. That's just showing what I just described. Commas are separating values. Semicolons are terminating lines. Does every line have to end in a semicolon? No. # include doesn't have a semicolon. Int main doesn't have a semicolon. In general, anything that has a brace before it is not going to have a semicolon on the line above it. That's just, you'll get real used to when you use them. When you don't use them is after if statements, after while statements, and other loops, and then after a function declaration, which looks like this. And I guarantee that some people have put semicolons after loops, after whiles or ifs, and it won't work, and I'll probably even do it accidentally up here. That'll make more sense when we hit those. So the rules of the grammar that must be followed when writing a program are known as syntax. The syntax dictates the keywords, the operators, the programmer defines symbols, and punctuation. So what is syntax? For example, in French, the adjective typically follows the name of the object. So in English, we say it's the red car. But in French, you say car red, except you don't use those words, right? And so text is awfully important. Grammar is awfully important. If the grammar is wrong, we won't even be able to understand a sentence. Like, read, Lord, I, rings of, whatever. You could probably figure out what that means. And suppose there was a period there rather than there, and suppose we put, some quotes around here, Okay, That is all the components of I forgot a word, didn't I? Of a sentence in English. But it's completely garbled. The stuff's in the wrong order. If you try to diagram it like you had to do in junior high or high school, whatever, it wouldn't make any sense. If you told somebody that, if you said that, you spoke it aloud, and wouldn't understand it. The syntax is wrong. It doesn't follow the right syntax. Now, English is way more forgiving than a computer is, right? So you can kind of make sense out of it even when people are not using the right syntax. Like if you're talking to somebody, who's, they're born in France, they're picking up the English language, they may say things a little bit wrong, but you still understand them. But in computer programming, you pretty much have to follow the exact grammar, the exact syntax that it defines. Things like where your semicolons go and your commas go and putting code inside braces. All those need to be followed pretty exactly or you will get what are known as syntax errors. And if you have syntax errors, the code doesn't even run. And if you've done some of your homework, you probably already have bashed your forehead against the keyboard trying to solve syntax errors. So variables are the named places. It's a named location in memory that holds a value. I don't like this definition. I have a much more specific one that I want you to remember. A variable is a named location in memory that has a type, a name, and a value. In fact, I just repeated name twice, right? So I'm going to call it a variable is a location in memory that has a type, a name, and a value. So for example, in that payroll program, we had a variable called hours. That's its name, hours. That's its type, double. What double means is that it's a double precision floating point. Do we care at this point at time that it's called a floating point or whatever? We know exactly what that means? No. But that's its type. There are many different types of variables. There are ints, there are floats, there are longs, there are longs, there are doubles, there are bytes. If we scroll way up here, maybe it's on the next chapter, we'll see the listing of all sorts of different types of variables. All we need to know for now is that this particular kind, double, supports floating points. And if we used another kind, int, standing for integer, you can't use a decimal point. So I should save this PowerPoint and actually upload it because that's how I want us to define what a variable is. So we use several variables in this program that I showed you on the last slide. Hours, rate, and pay. The hours is what they typed in, the rate was what they typed in, and the pay was what we calculated in response. To define a variable, you have to define your variable before you can use it. If you're a Python programmer, you didn't have to do this. In C, C++, Java, C#, all sorts of other what are known as strictly typed languages, you have to define your variable before you use it, and once you define it, you can't store anything but that type of data in it, unless it can be easily converted to that kind of data. For example, hours is a floating point value. So could you stick somebody's name in there? Hours equals, quote, Jeff. No, you couldn't do that because it has to be a number, because that says it's a number. C++ is a strictly typed language, meaning that once you declare a variable, it can only hold data of that type or something that can be easily converted to that type. What do I mean by that? Well, double means floating point, right? So you could type that in. But if you just type that in, even though that's an integer can be converted to a floating point, right? You just tack that onto it. The computer does that automatically. So anything that can be converted to this type could be stored into there. But the statement that I want you to remember is once a variable is declared, it can only hold data of that type. Many different types of data. So there are many different type words besides int and double. Each variable holds a specific type of data. Yes, sir?
Okay, so you said that, whenever you define it, you can only hold that type of data. Is there a way to convert that? Like, if you wanted to take an integer and turn it into a
Yeah, you can convert from one format to another.
Would you have to redeclare it?
And no, in a lot of places, you may have done something like this in Python, if you've done Python. A is equal to input, and then A is equal to integer A. That's totally not going to work. What you would do in this case is you would do A is equal to input, and no. You would type CIN into A, and you would have to have declared A as an integer to begin with. Now, if you had reason to convert a double into an int, there's a way to do that, but they need to be different variables.
Is a double the same thing as a string?
It's the same thing as a floating point. As a matter of fact, let's start listing our data types, because these words were used before we ever actually hit a declaration for them, and that's just because languages, programming books are hard to write. You have to understand a lot of programming, and so they can't always do things in the right order. There are ints, which stands for integers, which are whole numbers. There are strings. I'm going to put string above int, which holds text, series of characters. It could even be no characters at all, but that's still a series of characters. So, and then we'll put some examples. And then there's double, which is a floating point value, a non-integer number. So, string name is equal to Fred. Int age is equal to 32. Double weight, we're really crazy about our weight and we want to measure it down to the tenths, is equal to 168.2. Like that. Some of these can be converted cleanly to the other. You can take an int and store it in a double, no problem. You can even take a double and store it into an int, and this particular language will round it off. It'll drop to 0.2. If we did this, age is equal to weight. C++ doesn't give you an error, but by the time it's done, since age is defined as an integer, it's equal to 168. It dropped to 0.2. If you copy this integer into weight, then weight's going to equal 32, which is equal, 32.0, which is pretty much the same as 32. You wouldn't lose any data that way. So if you're taking a floating point and storing it into an integer type, yeah, it'll round it down. You could lose a little bit of data.
Okay, I hate to ask you too
Oh, please ask.
So what's the benefit of calling it a double instead of establishing it as a float? Like there is the float command.
There is a float type. A float is a 32-bit data type. Whoa, go away. And a double is a 64-bit data type, which means it can hold much larger values, much more precise values. And I didn't give you all the big lecture about bits and data yet, because I made the Java students sit through it, and I didn't want to just turn around and do it to y'all again. But the number of bits dictates the largest value that can be held. If you have a 4-bit chip, like in the old original Ataris, the largest number, it can hold a range of 16 values. All you could display on the screen was 16 colors. Then if you had an 8-bit chip, bits being zeros or ones, like in your original Nintendos, and your Commodore 64s and Atari 800s and all that kind of computer, you could hold up to 256 values. So that's a 4-bit. That's an 8-bit. That's a 16-bit. I'm not going to write out all those ones, okay? But it can hold 65536 different values, which is why this Genesises and the Super Nintendos displayed a lot better graphics than the than the regular 8-bit Nintendos. It could display a lot better colors, and the resolution was higher. The more bits you have, the larger the values you can have, and the more memory addresses you could address. And the Nintendo programs had to be very small, so you couldn't write something that was just gigabytes upon gigabytes upon gigabytes of data. Larger chips with more bits can address larger amounts of memory. There is a formula for converting that to that. It's 2 to the power of n, where n represents the number of bits. So 2 to the power of 4 is 16. 2 to the power of 8 is 256. 2 to the power of 16 is 65536. So what about 32 bits? 2 to the power of 32 is about 4 billion, I believe. Whoopsie. Can I type some commas in here? Are you going to let me? Okay, I'll just copy you and paste you. Thousands, millions, billions. So with 42, where'd that come from? 32. 32. Notice that these are doubling. A 64-bit, you know, you had your 32-bit chips inside your computers, you know, and you may have heard of Windows 32 versus Windows 64 or whatever. The absolute largest amount of RAM that a 32-bit chip could have addressed is 4 gigabytes. Giga meaning billion. 4 billion bytes. But if you have a 64-bit chip and a 64-bit operating system, it can go past that barrier. And this is just an astronomical number. If I type in 2 to the power, by the way, don't be fooled. Just because I'm typing to the power of inside Google doesn't mean it works in C++. It doesn't. There's no exponent operator in C++. So if I ask you how to calculate 3 to the power of 7 on an exam, don't just write 3 up arrow 7. Maybe how you expressed it in other classes, but it doesn't work in our programming language of choice. So 2 to the power of 64 is just a huge number. It's 18 followed by 18 zeros. Huge, huh? So the leap from 32 bits to 64 bits has made computers that can access astronomically large amounts of memory. Taking this back to C, ints are what are known as 32-bit values. So they can hold numbers from about -2 billion up to a +2 billion. There's another data type, a 64-bit integer data type, and it has an absurd name, long. I apologize for that absurd name. I didn't make it up. And it can hold values between 9 to the power of 18, 9e to the 18 in exponential notation, a 9 followed by 18 zeros, up to or from negative, I don't know what that is, super quinzillion, you know, to +9 e to the 18, a +9 followed by 18 zeros. So the difference between a 32-bit type and a 64-bit type is that every number takes twice as much memory to hold, but you can hold much larger values. The same thing is true of floating point numbers. You have floats, which are 32 bits. And then you have doubles, double wides, which are 64 bits. And I don't remember the exact values of the ranges, so I'm going to leave them off. Same idea, though. 64 bits can hold much larger values than 32 bits. Why is our textbook showing the use of doubles rather than floats? I'm not quite sure. In Java, double is the default floating point type, so all the textbooks always show double. Programming texts often use the word float because that's easy to associate, right? Float stands for floating point. Integer stands for int. Boom, that's easy. But then the books start throwing double letters.
Okay, I have one more question.
Please.
Do doubles, would those conflict with any 32-bit operating systems?
No. The operating system, the compiler saves it in such a way that it doesn't matter about the operating system. It's a separate thing. Good question, but the program, when the compiler converts your C code into an executable, it allocates the right number of bits for your data type and it treats them appropriately, regardless of what the operating system is. A double is a double regardless of whatever operating system or whatever architecture you're on.
Does it hurt to just use double all the time instead of float?
I don't think so. Not at all. Yeah, it uses a couple more bytes per number, but if you have a 2 billion bytes of memory on your computer because you have a 2 gig computer, is it going to matter that your 8 numbers are using a couple extra bytes? No, it's not. What do I mean by bytes? A byte is a collection of 8 bits. A bit is the smallest number that's either a 0 or 1. Can I type number rather than bummer? Number of in a computer, it's a 0 or 1. Who made these up? Well, at one time, I'm not going to even go into that. So ultimately, everything in your computer is a 0 or 1. If you're sending data down a fiber optic, it's got a laser shining in that light, and all it's doing is shining either off or on, off or on. Off means 0, on means 1. If you're reading data from a CD-ROM, then the CD-ROM burner burned pits into that aluminum layer, and if the pits are shaped a certain way, they're a 0. If the pits are missing, it's a 1, or vice versa. In your RAM, there's a whole bunch of billions upon billions of transistors, and if those transistors have charged silicon that are indicated in one way, it's a 0. If it's another, it's a 1. Back in the old days, you had vacuum tubes. If the tube was glowing, it's just a light bulb, then it was a 1. If it's not glowing, it's a 0. Before that, they had mechanical relays, where if the relay was closed, it was a 1, and if it was open and no electricity was flowing through it, it's a 0. So it's all 0s and 1s. Those 0s and 1s are combined conceptually for our ease of use into 8 bits each. So this int, how many bytes has it got in it? 32 divided by 8 is a 4-bit type. A long is a 64-bit type. So how many bytes does it have in it? No crickets. Come on, somebody say it.
8.
Yep, 64 divided by 8 is 8 bytes. So how many bytes are in a float?
4.
You know how to do it, but I want somebody else to say it now.
4.
All righty, 4, yeah, and then how many bytes are in that guy?
8.
8, okay, thank you. All righty. I'm almost tempted to go off and do the whole spiel about binary. I think I'm going to hold off on it. Let's get through this chapter. So the variable definition specifies the type of data it can hold, and it specifies the variable name, and the type specifies whether it can be floating point or not, and the largest values that it can contain. Input, processing, and output. Generally, this is the flow that all programs do. Usually much more complex than this. But it gets input, it processes that input, and it displays a result. Why do I say that? Because a program that did the very same thing every time you ran it because it didn't ask for input would be pretty boring. Like if Pac-Man didn't take any input, Pac-Man would run over to the edge of the screen, and he would just sit there and a ghost would eat him. Boring. He needs to accept input so that he could be going all over the place. So input, you type in, your age and your weight, or you type in your payroll or whatever, and then that gets processed. Some calculation is performed on it. And then after it's processed, you display the results. Can you display the results before you process it? No. Cool. Can you process it before you have your input? No. So generally these things go in this order. However, this is not showing looping. And looping is a very important part of programming. Why? Because if you're playing a video game and it just executed once, went to the end, maybe Pac-Man moved a whole pixel and then the program ended. Programs are constantly looping, sitting there waiting for you to do things. Your game, Candy Crush or whatever, is sitting there waiting for you to touch on the screen. Your video game is waiting for you to type on the keyboard or use the control pad or whatever. And it's doing that over and over and over. And each time you press a key, it may change something. It'll process that data, and then it'll update the screen based on that. Your character moves to the left, or your crosshairs move up, or your Candy Crush block starts to fall, whatever. And so it's constantly looping. And so we'll be talking a lot more about loops after a while. But even with a loop, it's doing this kind of stuff. Getting data, processing it, and then storing it. You can get your data from a keyboard, from files on disks. If you're writing more things like software for an automobile, maybe you're checking for temperature, or the amount of gasoline that the sensor says you have in the gas tank, or the pressure of the tires, There can be all sorts of different input. And then just display the results as output. There can be all sorts of different output. You could display something on the screen. You could save it to a file. If you have one of those keyboard loggers that's tracking everything you type so that some nasty spy can see what you're typing, then it's being sent across the internet. That's another form of output. In olden days, people saved their output on paper, punched paper tape, and then on punch cards. And then you had your printers with the scrolling, text. Nowadays, people display stuff on screen, obviously. So the programming process. Here's what we're going to learn to do. And pretty much we already know how to do this stuff because we took Python, most of us. You define what the program is to do. If you can't define the problem, you can't write a program to solve it, right? If I say, okay, I want you to write a program that converts, pounds to kilograms. And that's all I say. Well, you can't write a program that converts pounds to kilograms. Just, what is your pounds? Here's your kilograms. You have to know the formulas. Clearly define what the program is about to do. And then this starts sounding like Zen, Buddha. Visualize the program running on the computer. All right, whatever. Use design tools such as a hierarchy chart, flowcharts, or pseudocode to create a model of the program. Are we going to do that? No, I don't think I'm going to make y'all draw flowcharts, hardly at all. I may give you a flowchart and ask you to write a program from it, but that's because I've done it for you. You check the model for logical errors. All right, this is all well and good, but what are we going to do in this class? Most likely, I'm going to give you a concept like this, define what the program to do, and I'll either ask you to get the formulas or I'll provide them for you. And then you're probably going to skip creating a model. Instead, you're going to create code for it. You type the code, you save it, you compile it, you run it. You correct any errors shown during the compilation. You fix all the syntax errors. And then you wash, rinse, repeat, keep doing that. Then run the program. You give it test data. If it's not giving you the right answer, you continue to correct it. You go back to 5, you type code in, you correct it. You keep repeating over and over until it's no longer giving you any errors based on your input. And then when you're testing your program, you're not only testing to make sure it works, you're testing to make sure you can't make it fail. Because if you write a program, you test to see if it works. You go, okay, I weigh 100 pounds, and then it tells you, okay, great, you weigh 55 kilograms, and you look it up, and that's right, and you say, I'm done. But what if you type in something wrong? What if you type in your pounds with a decimal point? Does that cause the program to blow up? In this language, it probably won't, because C++ is happy to convert a floating point number into an integer. Other languages, it would cause it to crash. The program would just flat out not work. Or what happens if you type in some garbage? You type in A, B, C rather than a number, because your keys were off. That would cause the program to crash. We will learn some ways of correcting some of these, but some things we will not probably approach into fixing all of those problems. But generally, you need to test your program to see if you can make it fail, not just to see if you can make it work. And you want to try as hard as you can to make it fail so that you can at least tell the user not what to do, and hopefully you could correct it so that it wouldn't fail under those states. Procedural and object-oriented programming. Now this slide's not going to make much sense, but procedural programming focuses on the process. Procedures and functions are written to process data. Object-oriented focuses on objects which contain data and the means to manipulate the data. Messages are sent to objects to perform operations. Now that sounds like gobbledygook, probably. Maybe if you stared at it for a while, it makes sense, but when I was just reading it off, it probably didn't. What procedural programming is typically, I'm going to start at the top, and I'm going to find some data, and I'm going to do something with that data, and I'm done. What object-oriented programming is the idea of breaking things down so that you have clusters of data, clumps of data. This window is an object. This menu is an object. You might write a program that tracks somebody's, height and their age and their weight. So your program has 3 variables for height, weight, and age. And then it does something with them and it quits. An object-oriented programmer might say, okay, I'm going to define what a person is. I have a person, and that person has a height and a weight and an age. And so instead, you're dealing with clusters of data that create objects. And then you have ways of manipulating that data. It's kind of a different focus. A lot of what we do at the beginning is going to be procedural programming. We're going to be using object-oriented programming just a little bit off and on, but you're going to learn a lot more about object-oriented if you take C# or Java. C, the original C language, was written as a purely procedural programming language. Object-oriented programming hadn't even been invented when C was invented in 1970. C++ was redesigned completely to support object-oriented programming, but it became a much more complex programming language at that time. A lot of what we do looks like 1970 style C code, but not really. It did change a lot since then. All right, that's the end of chapter 1. Let's go to chapter 2.
Didn't you want to save it because of that definition you put in
Yeah. Let me make that change. Or why don't I just post it on the news? Or why don't we take notes and then you have to check the notes? We'll do that. Okay. Our definition of a variable. A location in memory that has a name, a type, and a value, and is used to store a value. Int x equals 3 has a type, it has a name and a value. You can create a variable that doesn't have a value. Yet, if I do this, int y, it's called uninitialized. It's like you have a box but nothing in it. Does it really have nothing in it? Not really. I'm going to launch Visual Studio and do something like that. Yes, sir.
What's the difference between int and void?
Void means no value whatsoever. Very good question. And you use the word void when you're defining functions. So we haven't really talked about defining functions yet, but I can give you an example of it pretty easy. Let me first make just an empty project. Y'all may as well type along with me so that we have something to upload as a daily assignment. So I load up Visual Studio, I right click on source file and do add, new item, and let's just give it a really clever name of August 31st. Give it a C++ name, file type. And then we're going to have to type in all that boilerplate that we type every single time, unless you make it a file and copy and paste. # include IO stream. And by the way, you can put quotes around these things when you're doing # include, but it means something very different. We'll talk more about that later. Okay. I always include string, even if we don't use strings. Then I'm going to add the line using namespace std. And I'm kind of going over this fast because I'm expecting y'all to have this stuff memorized pretty soon, where you could sit down and do this off the top of your head. And if you're using Windows, you're going to want to add this line. If you're a Mac user or Linux user, you probably won't. System pause. And all of our code's going to go here. Now I'm going to build and run it just to make sure that I don't have any syntax errors. Build early, build often. Why? Because it's better to correct syntax errors rather than type 500 lines of code and then have 40 errors to fix. Alrighty, I built it. It didn't have anything in the error list. We're all good. Okay, so let's define a variable, int x. And now I'm going to display that variable. I'm going to send x to the output. Now that's ENDL, not END1. I just say that because sometimes people see that and type in a 1. But you've already used that by now. Now what's it going to print? Really good question. We don't know what it's going to print because this is an uninitialized variable. Some languages won't even let that compile. It says, hey, I couldn't print out x if you never gave it a value. C++ isn't that picky. If I build it, it may display a warning there. Oh, look at that. It did display an error. Let's go look. Use of uninitialized local variable. What do you know? It just flat out refused to do it. That's a change to the language since olden days. That's an uninitialized variable, which I saw by looking at the error list. It will not do that. I have to give it a value before it'll print x out. All right, yay. I gave it a value, it printed it out. I'm proud. Let's do something a little bit more interesting. We're going to ask for some values and we're going to use a formula to display some output. So we're going to have some input. I'm just adding comments here, but comments, there's nothing wrong with that. We're going to use some processing and we're going to use some output. So I'm going to define our problem first. Here's what our program is supposed to do. Calculate a user's awesomeness quotient. This is totally silly, by the way. It's not useful at all. We could make it do something more useful. Okay, but anyways, what is a user's awesomeness quotient? Here's what the algorithm for it is. Ask the user for their age and their height. Calculate their awesomeness, which is age times height. The older you are, the more awesome you are. The taller you are, the more awesome you are. And I'm sorry, shorter people. Like I said, this is totally silly. Then display their awesomeness. This is dumb, but it's not going to take as long. Right? So that's our problem. That's our programming assignment. This is our algorithm here. Ask the user for their age. This is the formula. Awesomeness is equal to age times height. So what variables are we going to need to solve this problem? At least two, right? We got to ask for their age. We got to ask for their height. And then probably a third to store their awesomeness. So let's do that. And I'm going to use doubles rather than ints, just because some user may want to say that they're 65.3 years old. I never am that precise, but they might be. So double age is equal to 0. Double height is equal to 0. Why am I initializing those values? It just makes me feel good. We're going to ask the user for this data, so are those initialized values necessary? Not really. Now let's ask them for their values. I'm going to zoom this again. How do we ask somebody? We prompt them. What is prompting? Prompting is when you display a message and then let them type in something. So cout, what is your age? And I'm not going to use ENDL because I want them to be able to type in the answer right next to the question, right? Now CIN into the age variable. Got to get the arrows going in the right way. righty. And we have to do the same thing for their height. You can do that yourself. C out, arrow, arrow, what is your height? CIN in the height. But I'll do it too. But we better specify in what units. What is your height in inches? Otherwise, they don't know, you know, whether they're supposed to type 60 or 5 or, you know, measure it in yards, whatever. I guess we could ask for their age in years. I'm going to go back and add that. What is your age in years? Now, we have to calculate their awesomeness. Double awesome, that's enough, right? Is equal to age times height. And then print, nope, I'm completely wrong language there. That's starting to look like Python or Java, sorry. C out, you are, end quote, awesome, arrow, arrow, percent awesome. I'm going to put this on the next line. And I'm going to use /n rather than ENDL there, just to kind of get you used to the idea that you could use either one. There's no real preference, except if I'm already in a string, then it's only 2 more characters to type /n, whereas to type in ENDL, I have to type in 6, you know, arrow, arrow, ENDL. But if I'm not in a string, I'm not going to open up, you know, a new string just to do /n. Now this was all actually part of processing, so my comment's in the wrong place. I'm going to move that comment up. If you're using Windows, this won't work quite on a Mac. Move to the cursor where you are, hit home to go to the beginning, hit shift arrow down to highlight that line. Okay, and this is really wild, but you can do it. You could grab that line and move it up. Are you really going to do that? No. Instead, you're going to hit Control X to cut, and you're going to hit Control C to paste. Really, I did all that just to get that comment up there. But people wonder how I'm highlighting and cutting and pasting so fast. I try to slow it down. That's how I do it. So this output line I want here. So if we look at it, we have broken our program up. We have input, we have processing, and we have output.
I've got a question. What does the /n do?
/n means go to the next line. It's actually the exact thing as doing ENDL.
Okay.
What does the N mean? It means new line. What does a slash mean? It's what's known as an escape sequence, meaning don't print a slash.
Right.
Instead, you're going to do something special based on the letter that follows it.
See, I was using that, but I was using the wrong slash. I was doing
Yeah, if you do /, it doesn't look right. So \T means tab. \N means new line, and there's a couple others.
And so when do we want to use the...
I use \N if I'm already inside of a quote, like this.
Okay.
Because otherwise I have to do that, and that's like 6 more characters. But to be consistent, I could always do that. Absolutely nothing wrong with doing that. One reason for not doing that is if you go into other languages like Python or Java or whatever, you don't have ENDL.
Right.
So I tend to do that if I'm in a string. Doesn't matter which. I'm going to leave it with ENDL now. All right, I'm going to run it. I may have typed too fast. I may need to zoom up and down for y'all, but I want to see if it works. What is your age in years? Well, I'm really old. I'm 98. What is your height in inches? I'm kind of short. I'm, 42 inches tall. I am 4,000% awesome. Okay, like I said, that was stupid. It just shows you the idea. So if we're looking at our code and we come back and we see this code here, int x is equal to 100, we don't really need that, so I deleted that stuff. Okay, it's 9:23. We have time. to do a slightly more useful program. What this one is going to do is there is a measurement known as BMI, which stands for body mass index. And what body mass index does is it represents your weight as opposed to your height. And so, you know, if you're Kate Moss and you're really thin, then you'd have a low body mass index. And if you're a linebacker who's really tall, then you're going to have a high body mass index. And then if you look up these charts online, they'll say, oh, if your BMI is above this, then it means you're overweight, and if your BMI is under this, it means you're underweight. We don't really care about that. We're just going to write a program that calculates it. And it's not considered a really good measurement of health, because if you're muscular and large, then it's going to put you in the overweight category. And if you have a thin skeleton frame, then, you know, anyways. So don't use it for anything, you know, serious. Don't make judgments on it. But we are going to make a BMI program. BMI, measurements. We need two things. We need as input their height in inches and their weight in pounds. Based on that, we can calculate their BMI. I never can quite remember the body mass BMI equation, so I'm going to look it up. BMI, inches, pounds, formula. And you'll see why I can't quite remember it. 703. You multiply by 703. Okay. Let me go back and make really sure I had it. Okay, so it's your weight times 203 divided by the square of your height in inches. So BMI is equal to weight times 703 divided by height times height, like that. That's our formula. So this is what our program is going to do. It's going to be pretty similar to the other one. Once we calculate the BMI, we're going to display the BMI, then display the BMI. Very similar to the other one, except it's not as absurd as multiplying their height by their age. So let's start a new section. We could start an entirely new program, right? But time is of the essence. So let's go down here and do it again. We already have their age. We don't need their age. We already have their height in inches, but let's write the whole thing as though we needed to start over again. So double IN for inches is equal to 0. Double LBS for pounds is equal to 0. Let's ask them for their weight and their height. So C out, what is your height in inches? Cn into the IN variable, inches. Then C out, what is your weight in pounds? CIN into the pounds variable. Now we need a new variable to hold their BMI. Double BMI is equal to pounds times 703 divided by inches times inches. And let's print it out. C out your BMI, or the calculated, BMI calculated as arrow, arrow, BMI, arrow, arrow, ENTL. Sorry, I'm just going to test it and then I'm going to bring the code back. Alright, what is my height in inches? I'm a linebacker, I'm really tall. I'm 6'8", so that's what, 80 inches? I don't know. What is your weight in pounds? I'm 300 pounds. My BMI is 32 point whatever. I'm just going to trust that that's right. Yeah. Okay, so that's our formula for calculating BMI. I'm trying to think of a programming assignment that y'all are ready for, besides temperatures of conversion of pounds to kilograms and stuff like that. Something that would ask for two variables. It's not really occurring to me. Let me see what I've done in years past. Okay. The one that I'm going to ask you to do has got more than two variables in it, but don't panic, you just do it as easy as this, right? Instead of just asking for two things and having two variables defined, you're going to need more. So here's what the assignment's going to be. Write a compound interest calculator. Ask the user for D, or D at depth for initial deposit, and then R, which equals the interest rate expressed as a fraction. In other words, like 0.06 equals 6%. Then you're going to ask for the number of years. Let's do T is equal to number of years. Trying to kind of follow the variables that I see here. Okay, once we do that, we calculate their final value. You know, you deposit $10,000 at an interest rate of 10% over 10 years. What's that going to do? Here's the formula for that. Final is equal to D, the initial deposit, or DP, the initial deposit, times, and you aren't expected to know all this, I had to look it up, 1 plus the interest rate divided by 12. We're assuming that we're compounding this 12 times a year. To the power of n times t. Now we haven't learned about how to do this yet. So I'm going to rewrite this in pure C. Double final is equal to deposit times 1 plus R divided by 12, but I'm going to use a function called POW because we're raising something to the power of, divided by, or to the power of, n times t. That's your formula. Then print out the final amount, or display the final amount. I'll prettify this, right? But it should be pretty easy. You're asking for 3 variables rather than 2. Sorry, I keep forgetting I need to drag this over. Then you're going to calculate the equation like this. I'm giving you the whole formula. Like that. And then display the final amount. Not too bad, right? Pretty close to what we've done.
Are you gonna put it on D2L?
Oh, absolutely. You don't have to memorize it or look up the video. Okay. Like I said, I'll rewrite it to make it prettier.
Alright.
Alrighty, guys. Let's make a Dropbox for what we did today. Refresh your Dropbox. You'll see Dropbox C. And I'll create a Dropbox. It'll be homework assignment 2.
I got a quick question.
Sure thing. What's your
So
question?
whenever we did that second one about the BMI,
Right.
I started a new one and I'm not sure if I wrote on top of it or saved it, but I'm not sure where it went.
Yeah, let me take a look to where you saved it.